Okay, so if you've made it this far, we get to take a look in this screencast at derivatives of hyperbolic trig functions. And you may be saying to yourself, I have never heard of hyperbolic trig functions, and you may very well be right. This may be something you have absolutely never ever seen before. And so I would like to introduce them to you very briefly. The first hyperbolic trig function is the hyperbolic sine function, and you may see this button on a calculator and wonder, what the heck is that? That is the hyperbolic sine function. This is the hyperbolic sine function. It is pronounced cinch. Oh, maybe we'll say it like that. It's pronounced cinch, cinch of x. And cinch of x is e to the x minus e to the negative x over 2. And it looks roughly like this. Doesn't look a thing like the regular American sine function. Not a thing. Over here is the cosh function. The cosh function is the hyperbolic cosine function. And the hyperbolic cosine function is e to the x plus e to the negative x over 2. And that function looks, you're not going to believe this. Yes, you are. Like that. That's 0, 1 right there. And you're thinking, really? That doesn't look a thing like the cosine function. Why are these called trig functions? Oh, you ask an excellent question. You may remember with trig functions that sine squared plus cosine squared was 1. But with hyperbolic trig functions, cosh squared minus sinh squared is 1. And you can check that in the privacy of your own home. Cosh squared minus sinh squared is 1. And that puts these functions on the right branch of a hyperbola. And since they're on a hyperbola, that makes them hyperbolic trig functions. So you may be wondering, who cares? Well, again, these functions are smooth. And since they are smooth, they have derivatives. And very curiously, if you were to take the derivative of the sinh function, the derivative of the sinh function is the derivative of e to the x minus e to the negative x over 2. And that's, oh gosh, I know how to do this. You just bring the over 2 along, and then you take the derivative of that, and the derivative of that, a little bit of chain rule. You're like, hurry up, Ritter, just do it already, but I'm waiting for you to kick in. Okay, there you kicked in, and you're thinking, wait a second, I have seen this before. Where have I seen this? There. The derivative of sinh x is cosh x. And this will not come as a major surprise to you. The derivative of cosh x is, oh, kick that chain rule in, sinh x, which is very similar to our work with circular trig functions. The derivative of sine x is cosine x. The derivative of cosine x is the negative of the sine of x. But in this world, the derivative of sinh x is cosh x, and the derivative of cosh x is sinh x. And those are things I would like you to know. You may also be curious to know that there is a hyperbolic tangent function. And the hyperbolic tangent function is exactly what you would think it is. It's sinh over cosh. And if you do sinh over cosh, you get something that looks like this. with asymptotes at 1 and -1. And in fact, there is a hyperbolic secant function. And the hyperbolic secant function is exactly what you think it is. It's the cosh function, but reciprocal. It's the reciprocal of the cosh function. And if you take the reciprocal of the cosh function, well, that looks like this. I think that's 1. Looks like that. So what's curious about this? Well, the derivative of the hyperbolic tangent function is the square of hyperbolic secant. And the derivative of hyperbolic secant is, as you would expect, well, you'd sort of expect it, I imagine. It's similar to our circular result, but it is not the circular result. It's the negative of hyperbolic secant, hyperbolic tangent. So again, thinking here, what do you have to know? It'd be nice if on some index card you knew that the derivative of hyperbolic tan is hyperbolic secant squared, and similarly for hyperbolic secant, the derivative is negative hyperbolic secant hyperbolic tangent. It'd be even nicer if you knew where that came from, but I think you can prove that, and that's not too hard to do. Similarly, the derivative of the hyperbolic cotan function, which is exactly what you think it is, turns out to be the negative of the hyperbolic cosecant function, which is defined exactly the way you think it is. Hyperbolic cosecant is the reciprocal of hyperbolic sine, and the derivative of the hyperbolic cosecant function is the negative of hyperbolic cosecant squared, hyperbolic cotan. So it would be nice if you knew those things. They're not a major part of our course. They're not something that I'm going to drill down on and give terribly difficult questions on just to make you go crazy. But they would be nice things for us to explore a little bit, to know why they are and how they are. And that would be the extent of it for me. Okay, so when we gather, we will practice our skills with this and with inverse trig functions and their derivatives. It's a lot to keep straight, but you have index cards, so I have confidence in you. I will see you soon. Thanks.